Hello, welcome to another AP Stats lesson. We're talking about measures of relative standing, called the Z-score in this case. So here's an example. You obtain a score after taking a test. You want to know how it compares to the scores of the others. Is your score above or below the mean? That's one way of comparing yourself. Are you above average or below average? And by how much? Does your score place you among the top 5%? Wouldn't that be nice? Of the class. Or does it place you among the top 25%? So if you get your, say, your SAT score and you're in the 95th percentile, that means you're in the top 5%. It means you scored better than 95% of all the people. If you get your SAT score back and you're in the 75th percentile, that means you're in the top 25%. You scored better than 75% of everyone who took the test. Answering these questions involves measuring the position or relative standing of a value in a data set. One measure of relative standing is called a Z-score. The Z-score is what we call, another name for this is called a standardized test statistic. It tells you your relative standing compared to the typical value. So the Z-score is corresponding to a particular event. It's in your formula packet. Here's what it is. A Z-score is you take your statistic minus your parameter. So a statistic is like something gotten from a sample. A parameter is something gotten from a population over the standard error of the statistic. So for us, for now, what that means, and this means different things for different scenarios. So for now we're talking about like average or other things that aren't too complicated. We'll get more into this in semester 2. But for now, you take some data value, you subtract it from the typical value. So this is called kind of like a deviation here. It's how far is your piece of data deviating from the typical piece of data. And then you divide it by the standard deviation, the typical deviation, and it gives you what's called a Z-score. So we'll do some examples here in just a second. The Z-score tells you how many standard deviations the data value is from the mean, or the typical value. How many standard deviations are you away? If you're a lot of standard deviations away, it's really unusual. The process of subtracting the mean and then dividing by standard deviation is sometimes referred to as standardization. Okay, because you're taking any scenario, it could be IQ, it could be SAT, and you're standardizing it to one standard deviation above the mean or two standard deviations above the mean. A Z-score is one example of a standardized Z-score, or a standardized test statistic. That's another way of putting that. The Z-score is particularly useful when the data distribution is mound-shaped and approximately normal. So that's what we're looking for, mound-shaped and did I say normal? I didn't mean to say that. You don't know normal yet. Mound-shaped and approximately symmetric. I didn't use the normal word yet. Okay. So that means for things like this. Mound-shaped and symmetric. Doesn't work for things like this. Doesn't work well for things like this that are skewed. Mound-shaped and symmetric. And a lot of things are mound-shaped and symmetric. For example, IQ is mound-shaped and symmetric. Here's what IQ looks like if we were to have a distribution. The typical IQ is 100. The standard deviation is 115. So some people would test higher than typical. Those would be these people. And some people would test lower than typical. And typically, for every 115, There's also an 85, which means the average is 100, so they average out. And for every 130, there's a 70. All right, and so the distribution would look something like this. It's going to be mound-shaped and symmetrical, roughly around 100. So my drawing's not perfect, but that's how it's going to look. Okay. So the question is, what is the Z-score of a person with an IQ of 100? And a Z-score compares the data value to the mean. That's kind of what it does. So how far is 100 from the average? Average is 100, 100. The Z-score in this case is 0, because that is the average. What's the Z-score of 115? How many standard deviations is 115 from 100? One standard deviation is 15. So it's one standard deviation away. The Z-score is 1 plus 1. What's the Z-score for a person with an IQ of 85? How many standard deviations? That's 15 this way. That's one. Remember, one standard deviation in this case is 15. So an IQ of 85, the standard deviation is -1. So the positive and negative tell you if you're above average, you're positive Z-score. If you're below average, you're negative Z-score. What about an IQ of 120? Now that's not a perfect. 120 is like in the middle. It's in the middle of 1 and 2. This is a 1 Z-score, this is a 2 Z-score. So it's in the middle of 1 and a 2. You can't just say it's, a third of the way there. Well, you can kind of do that. So here's what you got to do. You got to use the formula. You take your data value, which for 120 is 120, minus your mean, which is 100, divided by your standard deviation, which is 15, and that ends up being 1 1/3, basically 1.33. And that makes sense because this is 1, 115 is 1, 130 is 2, and 120 would be 1 1/3. An IQ of 70. Now 70 is right on the 2 mark. So this is -1 standard deviation. This would be -2 standard deviations. That's right there. -15, -15. If someone has a Z-score of 4.1, what is their IQ? Now that would be way the heck out here. So this is 1 standard deviation, 2, 3, 4. It'd be like way the heck out here. So if you want to figure this out, what you do is you use the equation, but you use it backwards. So the Z-score, and you'll see it like that with a little like asterisk, Z-score equals x minus mu over sigma. Notice I'm using mu here because it's the population. The entire average of the population is 100. And so the Z-score being 4.1 is x minus 100 over 15. Just plugging in some values. When you solve for that, you get 161.5. So a person with an IQ having a Z-score of 4.1 has an IQ of 161.5. This is actually Albert Einstein's supposed IQ, 161.5. If someone has a Z-score of 10.9, what is their IQ? So you run the same thing, 10.9 equals x minus 100 over 15. Do the algebra. This is about the extent of the algebra in this class. Multiply and add, and you get 263.5. That is the IQ. That's the largest IQ known, measured. There's a link here if you're online. You can go and click and read about that. Example 2. Bob took the SAT and scored a 1450. Not bad. Sally took the ACT and scored a 32. Not bad. Now the average SAT is 1060, standard deviation 195. The average ACT score is 21, standard deviation 4.5, 5.4. Who did better? So this is where standardizing is a good thing. So let's draw, here's the picture for the SAT. The SAT has a center around 1060 and a standard deviation of 195. So to find just a couple tick marks in here, 1060 plus 195 is 1255. That's one standard deviation away. Let's add 195 again. So there they are. Okay, that's a terrible symmetric. Let's do that again. This is called the bell shape. It's a bell curve. It's not bad. Alright, so here's what the distribution would look like. 1450 was his score. You can see that he scored 2 standard deviations above the mean. So Bob gets a Z-score of 2. Now we need to standardize Sally. So here's Sally. So this is the ACT now. The ACT has a distribution like this, where the average is 21. And then you kind of go out like that. And one standard deviation is 5.4. So this is 26.4 and 31.8. Now Sally got a 32, which is obviously above a Z-score of 2. In fact, we can find the Z-score of Sally by plugging in her score minus the average score divided by the standard deviation, which leaves with a Z-score of 2.03. So Sally did better. That's the power of standardizing. The numbers aren't always going to be the same, but when you standardize, you can see who's more impressive. This guy has a Z-score of 2, and she has a Z-score of 2.03. So Sally actually did better. Power of standardizing. Next, something called the empirical rule. In the scenario where you are mound-shaped and symmetric, this works every time. Approximately 68% of the observations are within 1 standard deviation. So the area under this curve, if we were in calculus, the integral here, would end up being 0.68. If we found this curve and did the area under the curve, it would be 0.68. And it turns out, so that's 1 standard deviation away. Within 1 standard deviation, 68%. Do that in blue. Within 2 standard deviations. So 2 standard deviations captures most of the data. You get 95% of all things fall within 2 standard deviations of a typical value. So we're looking at IQ. 95% of all IQs fall between 70 and 130. That's called so 95% are within 3, and then lastly, when you get out to 3 standard deviations, you're up to 99.7%. 99.7% of all of your data will fall within 3 standard deviations. So up here, IQ, 99.7% of people have an IQ between 55 and 145. So Einstein was like 4 standard deviations. So he's just out of this world. All right. What percent of IQs are less than 85? So 85 is 1 standard deviation less than 100. So what percent of IQs are less than 85? So that would be, so if this was IQ, here's the 85 mark. Remember, this would be 100. So that's going to split this up into this area and this area. So if this, I just made a mess of my drawing. If this is 34% and this half is 50%, we can do just a little bit of algebra here. Not algebra, that's 16%. So 16% here and 84% here. 16 plus 84 is 100%. So what percent of IQs are less than 85? 16%. What percent of IQ scores are greater than 2 standard deviations above the mean? So here's 2 standard deviations. Let's rerun this problem again. So 2 standard deviations kind of separates the graph here and here. It's 2 standard deviations away. So you got all of this added up on this side. So that's 50% plus 34% plus 13.5%. Okay. So what percent of IQ scores are greater than 2%? Well, this is the less than 2%, 2 standard deviations, I mean. And so greater, so 97.5 is on this side, and that leaves 2.5% on that side. Okay. Last thing, I'm going to let you read through all of this on your own. I don't need to read that to you. For a number r between 0 and 100, the rth percentile is a value of r, percent in the observations that fall at or below that value. So if you got in the 90th percentile, that means you scored at or better than 90% of the people that took a test. What is the 84th percentile of IQ? So we got to go back to the first page here. 84% would be 50% plus 34%, which is 115. So at 115, at an IQ 115, you scored better than 84%. So 115 is the 84th percentile. What is the 16th percentile? That's this problem. What percent of IQ scores are less than 85? 16%. So the 16th percentile is 85. It's just backwards. So like if this question was forwards, this question is backwards. It's just the opposite. You have that to do, and that actually takes us to the end of chapter 3. We will have a day of doing some AP problems from chapter 3. Here's your homework, and then we will have a quiz probably. I'm not sure when the quiz is off the top of my head, but it's probably going to be next week. All right.